In this video, we're going to take a look at the Model Mania Design Challenge from 2008. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where attendees are given a drawing like this and they're tasked with creating the part in SOLIDWORKS both as quickly and as accurately as possible. Now, if that wasn't enough, when they're finished with the part, they'll be given a second drawing with a series of changes and in some cases, such as this year, an additional task to perform. So we're going to create this part, and it's actually fairly simple. The real challenge comes in phase 2, where we'll look at simulation. For this, however, though, I am going to highlight the use of contour selections. This is a great example where the entire front view of this part can really be drawn in one sketch. And in fact, it's quite useful because a lot of the geometry is contingent upon one another. So let's go into SOLIDWORKS and start doing that. As I go ahead and create this geometry, again, keep in mind we will be using contour selection, so we can bypass some of the trimming steps that might be necessary. So in this case, I'll create the cylinder diameter and the bore through it, and then for the keyway, I'm simply going to go ahead and I'll type that width and we'll drop this on here. I'm going to locate this on the center by simply adding a midpoint relationship to the center. For the length of it, I'll dimension to the end of the keyway, and while holding my shift key, snap to the outside tangency of that circle. Now, you could trim this up. In some cases, you'll want to do this, but when you do that, notice what happens. It makes the keyway go underdefined. We can go ahead and add that dimension back that we removed, the 6, but it's still not located on the center. Well, if this keyway was centered, keep in mind, these two lines would be equal length. Likewise, another way to capture that would be to make these two endpoints vertical to one another. Finally, you can go ahead and also add a center line to the midpoint of this line and make the center line horizontal. There is one last way you can do this, however, without any construction geometry. You can right mouse click on this line and choose to select its midpoint, and then while holding the control key, select the origin and make them horizontal to one another. So as you can see, there's several ways to accomplish that task, and that's a very common task inside of SOLIDWORKS. Now I'm going to go ahead and start on the slot on the outside. The slot tool inside of SOLIDWORKS is perfect for this, and in fact the center of this slotted arc happens to be right in the center of this part, so we'll use a center point slot. I'm going to go ahead and drag this out and then just drag my slot up and then drag out the size. You'll notice I had add dimensions enabled, so a lot of the dimensions have been included. But notice this 15.59. That's not actually how we're going to call this out. Instead, we're going to define this by a radius value. So I'll just delete that and add a new dimension. We'll update these values to their correct numbers, and in this case, the angle will be 30 degrees. And you'll notice that this slot is still free to move around the part. Well, there's actually two here, and what we're going to do is offset these. Now, I could do the calculation and determine that the offset in this case will in fact be 6 millimeters, and it'll add that dimension automatically. But that's not how it's called out on the drawing, so I'm going to delete that, and again, I'm going to add a radius value. The reason is what if one of these ever had to change? I don't want to have to go back through and continually update that offset value. These were defined individually from one another, so that's how I'm going to dimension them. The next thing we want to do is capture this line on the bottom, which is also tangent to the bottom of this arc. We'll just window select those and make them tangent to one another. And then finally, there's an arc here on the top. For this, we're going to go ahead and use a 3-point arc and attach it to the two pieces of geometry. Now you'll notice we will want to go in after the fact and make these tangent to one another to make sure that they are in fact tangent. And then we'll go ahead and add this radius value of 175. Now the next thing we want to do is create this pocket in the middle here. And offsets, this is another great example of where we'd use it. We will want to reverse the direction to go to the inside, but notice I'm going to leave off this circle. And the reason I'm going to do that is I'm going to show another way to dimension arcs. So I'm going to drag these back, and I'm going to create this tangent arc that goes from the bottom here to this line here. Now you'll notice when I go to create it, they're obviously not tangent. Well, SOLIDWORKS actually presents you with the ability to add a relationship between the entity you just sketched and the entity you attached it to. In this case, tangent to one another. So that'll save you a few steps and not having to go back and add it later. Well, we mentioned previously the ability to hold down the shift key to dimension to the outside of an arc. Well, it actually works from the inside to the inside as well. In that case, I just simply held down shift while I selected both of those arcs to capture that 6 millimeter offset between them. The last thing I'm going to go ahead and do is trim off some of these extra pieces of geometry just to clean the sketch up a bit. So we have this sketch that represents the entire front profile. I want to now start creating geometry from this. So I'm going to go ahead and do this. I'm going to choose extrusion, and because there's multiple profiles in the sketch, SOLIDWORKS automatically enables selected contours. For the first feature, I'm going to just go ahead and select the cylindrical feature on the front and enter the 30mm depth for it. Now you'll notice the sketch goes away, it hides itself automatically, but we can go back into the feature manager tree and just reselect it. I'm then going to go ahead and choose extrusion again, and in this case this extrusion is 16mm wide. I will go in and use the offset tool though to capture that 2mm offset off from that back face. We've talked about that in previous videos, and we're going to do the same thing on this internal region here. In this case we're going to make it 14mm, and we're going to offset this 3. We're just going to add up the 2mm from the second feature we created and the additional 1mm that's needed. So we've got the bulk of the geometry. All that's left is to create a series of fillets. And if you've watched the previous videos in this series, you'll immediately know why I select faces, because it allows me to capture a lot of geometry all at once. But in this case, we are going to do these fillets in 2 steps. You'll notice that I create the fillets around the rib first and then the second set, and that's just to ensure that they're able to solve the way that we want them to look. Finally, there are a series of 4mm fillets on these front edges, and because they're only applied to those edges, that's what I'm going to select. So we've created the part rather rapidly, but if you look at the drawing, there's one other thing that's specified, that the material has to be applied to this part. Well, let's go ahead and do this. Applying the material in SOLIDWORKS is actually pretty easy. You simply right-click on the materials node in the feature manager tree, and you can select one from your favorites, and the AISI 1020 that's specified is here, but let's look at the edit materials library. It's a big library in SOLIDWORKS, but it does more than just say what the material is. You'll notice that it also captures all the physical properties of the part, including things such as the yield strength and the tensile strength, which we'll be using in a moment to perform simulation. Additionally, it's also going to change the appearance of the part to look like that material, and it will automatically define the crosshatch used in a drawing. So a lot of things are set when you set the material, not just the name or just the color, but a lot of different properties. So as we pressed OK, you can see that the part does indeed look the way it was supposed to. So let's go ahead and save this. I'm going to overwrite a previous example that I did of this, and we're going to go ahead and flip to phase 2. Now when we look at the phase 2 drawing, we can see that the part itself doesn't change a whole lot, but there are some very unique notes at the bottom. We're going to be working with configurations to create a second version of this part. Then with these 2 versions, we're going to perform a simulation in our example using Simulation Express to analyze the 2 configurations and determine which one is strongest. So let's start by going back into SOLIDWORKS and making the new configuration. We're going to go to the configuration manager and simply right click and choose to add a new one and give it a name. In this case, we're going to go ahead and call this phase 2 and simply press enter. We want to keep the appearance that we did before, so I'll choose no there. And we now need to make some changes. So I'm going to double click on this feature, and one of the first changes is the thickness of these change. So for example, this one changes from 6 to 14. Now you might think just update the value and hit enter, and this new configuration's updated. But be careful. When you do that, you'll notice that I've actually changed it in both configurations of the part. When you're changing dimensions for the first time, you'll want to be aware of the pull down to the right of the dimension. This pull down is where you can specify which configurations have this dimension, and by default they're always set to all configurations. So we're going to change this to this configuration and reset our default configuration. Now notice when I toggle between the 2, there's a noticeable difference. Let's go ahead and do that to a few of the other dimensions on this. In this case, we're going to change this 14mm over here to be 8mm, and the offset value from the back, we're going to go ahead and again, only in this configuration, change it to 6. Now, when we rebuild the part, you can see it's drastically different from the first configuration. So within one file, we have 2 slightly different versions of the same part. But now comes the interesting piece. We need to perform an analysis on this part to determine which is strongest and capture the factor of safety. For this, we're going to go ahead and use SOLIDWORKS Simulation Express, which is available in every version of SOLIDWORKS. You may have to register it if it's the first time you've used it, but it's free of charge to anybody using SOLIDWORKS. It'll guide you through the process step by step, but we're going to go rather quickly and just show how to do this. The first thing we need to do is add a fixture. Where will the part be constrained? And in this case, we're going to choose this bore going through the part. Then we'll go ahead and apply that by pressing OK and choose Next. We could have added more if we wanted to. Next thing we want to do is add a force. And in this case, we're going to apply a force of 400 newtons to the face selected here. The next step we'll see is where we can choose our material. Now we already specified this, so notice that simulation automatically captured the Young's modulus and the yield strength of the part. So we can bypass this step and go right to running the simulation. This will go rather quickly, and when it's finished, SOLIDWORKS will give you a preview of how those forces will act on the part. If it's unexpected results, you can go back and change how you entered the parameters, but in this case it looks good. So when we look at the results, immediately we can see that the factor of safety for phase 2 is 2.8383. Now, one of the other things we might be interested in is looking at the von Mises stresses of this part. Here we can kind of see how the stresses are actually acting and where most of the load has been applied to the part. And we can see it's kind of down in this area here. Likewise, if we go back to the factor of safety, we can actually say, show me anywhere where that factor of safety falls below 3 in this case, and we can see that the weakest area of that part is about right there. So that was pretty easy to solve, but we need to compare this to the other version. So let's go ahead and say done viewing results, and we could generate a report, but I'm simply going to close this for right now and save my settings. All that's needed to check the results on the default configuration we made originally is to activate it, restart Simulation Express, and we literally can just skip through these steps because all the properties and specification we've defined are exactly the same. We just need to rerun the results. So again, very quickly, SOLIDWORKS shows us what it's looking like. We'll say yes and continue, show me the results, and we can see that this part is significantly stronger with a factor of safety of 4.4364. So in this case, if we were to look for anything below a factor of safety of 3, nothing shows up. Again, you could see the von Mises stresses, and we can see that they've moved further down that web as well. And this is because the way we've designed the web, we've changed the cross section to better handle the way the load's been applied to this part. So we're done with that. As you can see, we went through this Model Mania design contest and not only made the part rather quickly, we were able to see how strong it was fairly rapidly as well and compare the two different results to one another. If you'd like to learn more about Model Mania or SOLIDWORKS World, I highly encourage you to visit the links in the video below the video or on the blog page depending on where you're watching this.